Hi everyone, I'm Sangeeta. Good morning all. Today we are going to discuss about the continuity, limits, some examples of limits and continuity. The last video we have discussed about the limits of a function of two variable, right? So in that class we were discussed about the limits, the difference between the limits of one variable and limits of two variable, right? Limit of function of two variable. I think you have understood that. So we can jump to the some examples corresponding to this limits, right? Limits of function of two variable, right? So for example, in this, I'm taking an example. Limit xy tends to 0, 1. Limit xy tends to 0, 1. Then what will be the 0, 1 means x tends to 0 and y tends to 1. Right? So the question is x minus xy plus 3 divided by x square y plus 5xy minus y cube equal to 0, x tends to 0 and y tends to 1. When I am substituting the value in this function, the answer is minus 3, right? So you just do it to find out the answer, right? So move on to the next question. So limit xy tends to 3 minus 4 root of x square plus y square, which is equal to root of 9 plus x tends to 3 and y tends to minus 3, square root of 9 plus 16, that's equal to root 25, which is equal to 5, right? So the third question is given by limit xy tends to 0 0 x square minus xy divided by root x minus root y, which is equal to limit xy tends to 0 0 x into x minus y divided by root x minus root y, right? So we know that a square minus b square equal to a plus b into a minus b. So here I can write this x minus y as root x plus root y into root x minus root y. Right? Is it clear? In the place of a, here root x. In the place of b, here root y. Right? I have just replaced that x minus y by root x plus root y into root x minus root y, right? So root x minus root y getting cancels, and then the remaining term is x into root of x plus root y, right? Here x tends to 0, y tends to 0. So when x tends to 0, this is 0 into root 0 plus root 0, which is same as what? 0, right? So we got the answer 0, right? I think you have understood that. It is very easy, right? Just to substitute that value. Okay. So I'll give some homework also in the later, right? So I'm going to discuss about the next topic is continuity, right? So continuity, the definition you have discussed, you have studied in the last semester, sorry, in the first semester also, right? So a function of one variable, y equal to f of x is continuous at the point. This, as in the case of function of one variable, the continuity means if it limit exists and there will be three conditions, right? So as in the case of function of one variable, function of two variable is same, not different from this function of one variable, right? So the three things are: f is defined at x0 y0, b limit xy tends to x0 y0 f of xy exists, and limit xy tends to x0 y0 f of xy equal to f of x0 y0, right? If these three conditions satisfied, then function f of xy is continuous at a point. Okay. And when you say that a function is a continuous function in the domain, take all the points in that domain, right? At each point in that domain, that function must satisfy these three conditions, right? Then we say that the function f of xy is continuous in that domain. Continuous at if a function is continuous at all points in that domain, then we say that the function is a continuous function, right? So I think, and what are the examples of these continuous functions, right? So as in the case of function of one variable, we know that the exponential functions, cosine function, trigonometric functions, logarithmic functions, these are examples of polynomial function. These are examples of what? Continuous functions, right? So similarly here also, the exponential function, trigonometric function, logarithmic function, etc. are continuous functions, right?